Advantages of the Internet. An Internet connection allows worldwide access to people and other computers on the network. The amount of information available on the Internet is growing rapidly every day. Public servers for various types of work and research are readily available to those who are connected. Public domain files and archives may be downloaded as needed. Electronic mail and interactive discussion groups allow users to communicate and share common interests with other users from around the world. Information is accessible 24 hours a day, 7 days a week. Information may be accessed within seconds of release, totally independent of geographical location and time. Personal and dynamic channel of contact with clients, customers, employees and vendors. An established Internet presence gives the user access to the Internet as a new mass communications medium. By taking the lead in quickly employing the tools of this new information technology, your business will gain enormous advantage in the worldwide marketplace. Basic networking concepts. What is a network? What is a protocol? Types of networks. Network components. What is a network? Two or more computers connected together. Communication and sharing. Hardware and software. Interoperable. A network is a group of computers that are able to communicate with one another and share data, files, programs, and operations. The computers in a network are connected via hardware and software. The hardware is what physically connects the computers in the network together. For example, telephone lines, fiber optic cables, routers and gateways, and the computers themselves. The software is what enables us to use the hardware for communication and exchanging information. Just as your brain tells your body parts how to function and work together, the software governs the way computers in the network communicate with each other and perform functions. Software that enables networking follows a set of rules that are generally referred to as a protocol. Networks can be interoperable. Networks can be interoperable. This means that different types of computers, using different operating systems, can be connected, communicate with each other, and share information, as long as they follow the network protocols. In summary, a network is a group of two or more computers, connected together through a physical infrastructure, that are able to communicate and exchange information because they agree to use software that observes the same set of rules, or protocol. What is a protocol? Rules for communication description. Format and method. Understood by different types of computers. History of the Internet. Fundamentals. Packet routing. Topics covered. History of the Internet. Fundamentals. Encapsulation and layering, Internet protocol, IP, layer model, IP addresses. Packet routing. Basic, static, dynamic, routing protocols, subnetting. Internet Protocol Suite, TCP/IP. IP, ICMP, UDP, TCP, ARP/RARP. IP over serial lines, PPP and SLIP. Domain Name Service Overview. User-level protocols. SMTP and electronic mail, NNTP and Usenet News. FTP and anonymous FTP, Telnet, Gopher, Archie. Ways, HTTP/HTML. The World Wide Web. Service providers, how to get on board. Internet culture and netiquette. Future of the Internet. A protocol is a standard set of rules that determines how computers communicate with each other across networks. A network is two or more computers that are physically connected to each other and able to share information. When computers communicate with one another, they exchange a series of messages. To understand and act on these messages, computers must agree on what a message means. Examples of messages include establishing a connection to a remote machine, sending or receiving email, and transferring files and data. A protocol describes the format that a message must take, and the way in which computers must exchange a message. Within the context of a particular activity, such as sending messages across networks, exchanging email, establishing remote connections, or transferring files. Think of an electronic mail message. Think of an electronic mail message. Both the format of the electronic mail message and the way that it is transmitted across the network are described and governed by a protocol. Protocols ensure that electronic mail messages are correctly formatted and transmitted from the originating computer to the destination computer. A comparison can be made to the rules that govern how letters are handled by the post office. There are different protocols for different types of network services. There are different protocols for different types of network services. For example, the Internet is based on the TCP/IP suite, or family, of protocols. Some of the protocols used on the Internet are Simple Mail Transfer Protocol, SMTP, to send and receive electronic mail. File Transfer Protocol, FTP, to transfer files between computers. Hypertext Transfer Protocol, HTTP, to transmit information on the World Wide Web. Network News Transfer Protocol, NNTP, to transmit network news. In summary, a protocol is a standard set of rules that governs how computers communicate with each other. Protocols describe both the format that a message must take and the way in which messages are exchanged between computers. Different types of computers are able to communicate with each other, in spite of their differences, when they agree to use a protocol that offers a standard format and method for communication. Some of the protocols used on the Internet are TCP/IP, SMTP, FTP, HTTP, and NNTP. Network types: Local Area Network, Metropolitan Area Network, Wide Area Network. Network components: Computer Server/Gateway, NIC, Ethernet Hub, Router, DSU/CSU. Server, gateways. In client/server architecture, a server is a single, high-powered machine with a large hard disk set aside to function as a file server for all the client machines in the network. A server could function as a file server, web server, mail server, FTP server, news server, and many other applications. A gateway is a computer that performs protocol conversion between different types of networks or applications. For example, a gateway can connect a personal computer LAN to a mainframe network. An electronic mail gateway converts messages from two or more different email standards. Network Interface Card. The Network Interface Card, NIC, provides the physical connection between the network and the computer workstation. Most NICs are internal, with the card fitting into an expansion slot inside the computer. Some computers, such as Mac Classics, use external boxes which are attached to a serial port or a SCSI port. Laptop computers generally use external LAN adapters connected to the parallel port or network cards that slip into a PCMCIA slot. Network interface cards are a major factor in determining the speed and performance of a network. It is a good idea to use the fastest network card available for the type of workstation you are using. The three most common network interface connections are Ethernet cards, local talk connectors, and token ring cards. According to an International Data Corporation study, Ethernet is the most popular, followed by token ring and local talk. Santangelo, R. 1995. NetWare Unleashed, Indianapolis, Indiana, Sam's Publishing. The Network Interface Card, NIC, provides the physical connection between the network and the computer workstation. Most NICs are internal, with the card fitting into an expansion slot inside the computer. Some computers, such as Mac Classics, use external boxes which are attached to a serial port or a SCSI port. Laptop computers generally use external LAN adapters connected to the parallel port or network cards that slip into a PCMCIA slot. Network interface cards are a major factor in determining the speed and performance of a network. It is a good idea to use the fastest network card available for the type of workstation you are using. The three most common network interface connections are Ethernet cards, local talk connectors, and token ring cards. According to an International Data Corporation study, Ethernet is the most popular, followed by token ring and local talk. Santangelo, R. 1995. NetWare Unleashed, Indianapolis, Indiana, Sam's Publishing. Ethernet. Local Area Network, LAN, developed by Xerox, Digital, and Intel. It connects up to 1024 nodes in a bus topology at 10 megabits per second over twisted pair, coax and optical fiber. Fast Ethernets are coming, including Fast Ethernet, which runs at 100 megabits per second, and Switched Ethernet, which gives each user a 10 megabits per second channel. Ethernet is the most widely used LAN. Token ring is next. Standard Ethernet, or thick Ethernet, requires a thicker coax cable, but can run as far as 1,640 feet without using repeaters. Attachment is made by clamping a transceiver, which is cabled to the adapter card, onto the main bus cable. Thin Ethernet, also ThinNet and CheaperNet, uses a thinner, less expensive coax that is easier to daisy chain together using T-type and C connectors. The transceivers are built into the adapter cards. Twisted pair Ethernet allows installed telephone wire to be used, and fiber optic Ethernet is impervious to external radiation. Both use a star topology for easier debugging of failed nodes. Ethernet is a data link protocol and functions at the data link and physical levels of the OC model, 1 and 2. It uses the CSMA/CD access method and conforms to the IEEE 802.3 standard. Hub. Central connecting device for communications lines in a star topology. Passive hubs add nothing to the data being transmitted. Active hubs regenerate signals and may monitor traffic for network management. Intelligent hubs are computers that provide network management and may also include bridging, routing and gateway capabilities. The hub star topology improves troubleshooting over bus topology, in which all nodes are connected to a common cable. Hubs can be added to Ethernet bus networks for improved network management. Both hubs and routers may be inserted into the middle of a network in order to improve performance and network management. Router. Computer system that routes messages from one LAN, local area network, to another. It is used to internetwork similar and dissimilar networks and can select the most expedient route based on traffic load, line speeds and costs and network failures. Routers maintain address tables for all nodes in the network and work at OC Layer 3. Routers are used to break apart the LAN into smaller LANs for improved security, troubleshooting and performance. Routers with high-speed, gigabit, buses may serve as an internet backbone, connecting all networks in the enterprise, DSU/CSU. Digital, or data, service unit/channel service unit, pair of communications devices that connect an in-house line to an external digital circuit, T1, DEADS, etc. It is similar to a modem, but connects a digital circuit rather than an analog one. The CSU terminates the external line at the customer's premises. It also provides diagnostics and allows for remote testing. If the customer's communications devices are T1 ready and have the proper interface, then the CSU is not required, only the DSU. The DSU does the actual transmission and receiving of the signal and provides buffering and flow control. The DSU and CSU are often in the same unit. The DSU may also be built into the multiplexer, commonly used to combine digital signals for high-speed lines. What is TCP/IP? A suite of protocols. Rules for sending and receiving data across networks. Addressing. Management and verification. TCP/IP stands for Transmission Control Protocol/Internet Protocol. TCP/IP stands for Transmission Control Protocol/Internet Protocol. TCP/IP is actually a collection of protocols, or rules, that govern the way data travels from one machine to another across networks. The Internet is based on TCP/IP. TCP/IP has two major components, TCP and IP. Envelopes and addresses. The data enables the network to read the envelope and forward the data to its destination. Defines how much data can fit in a single envelope, a packet. The relationship between data, IP, and networks is often compared to the relationship between a letter, its addressed envelope, and the postal system. TCP breaks data up into packets that the network can handle efficiently, verifies that all the packets arrive at their destination, reassembles the data. TCP/IP can be compared to moving across country. You pack your house in boxes and put your new address on them. You pack your house in boxes and put your new address on them. The moving company picks them up, makes a list of the boxes, and ships them across country along the most efficient route. This may mean putting your dishes and your bedroom furniture on different trucks. Your belongings arrive at your new address. You consult your list to make sure that everything you shipped has arrived, in good shape, then you unpack your boxes and reassemble your house. In summary, TCP/IP is a suite, or family, of protocols that govern the way data is transmitted across networks. TCP/IP protocols work together to break the data into small pieces that can be efficiently handled by the network, communicate the destination of the data to the network, verify the receipt of the data on the other end of the transmission, and reconstruct the data in its original form. What is an IP address? A way to identify machines on the Internet. A number. Unique. Global. Standardized. If you want to connect to another computer, transfer files to or from another computer, or send an email message, you first need to know where the other computer is. You need the computer's address. An IP, Internet Protocol, address is an identifier for a particular machine on a particular network. It is part of a scheme to identify computers on the Internet. IP addresses are also referred to as IP numbers and Internet addresses. An IP address consists of 4 sections separated by periods. An IP address consists of 4 sections separated by periods. Each section contains a number ranging from 0 to 256. Example equals 198.41.0.52. These 4 sections represent both the machine itself, or host, and the network that the host is on. The network portion of the IP address is allocated to Internet Service Providers, ISPs, by the INTERNIC, under authority of the Internet Assigned Numbers Authority, IANA. ISPs then assign the host portion of the IP address to the machines on the networks that they operate. Which sections of the IP address represent the network and which sections represent the machine will depend on what class of IP address is assigned to a network. There are 5 classes of IP addresses: Class A, Class B, Class C, Class D, and Class E. Classes correspond either to the size of the network, the number of hosts that the network can support, or are reserved for specific purposes, such as multicasting and experimentation. The diagram below compares Class A, Class B and Class C IP addresses. The diagram below compares Class A, Class B and Class C IP addresses. The blue numbers represent the network and the red numbers represent hosts on the network. Therefore, a Class A network can support many more hosts than a Class C network. Class A networks. Class A networks may have up to 16 million hosts within the network. If the first bit is set to 0, then the next 7 bits are the network number, and the remaining 24 bits are the host number. This allows up to 127 Class A networks. A value of 127 in the first field is reserved and is called the loopback. A loopback refers to an interface that allows a host to send packets to itself. This address is commonly 127.0.0.1. Class B networks. Class B networks may have up to 65,000 hosts. If the first 2 bits are 10, then the next 14 bits are the network number and the remaining 16 bits are the host number. This allows 16,384 Class B networks. Class C networks. Class C networks may have up to 254 hosts. If the first 3 bits are 110, then the next 21 bits are the network number and the remaining 8 bits are the host number. This allows up to 2,097,152 Class C networks. In summary, an IP address is a unique, numeric identifier used to specify a particular host on a particular network, and is part of a global, standardized scheme for identifying machines that are connected to the Internet. IP addresses consist of 4 numbers between 0 and 256, separated by periods, which represent both the network and the host machine. The INTERNIC, under the authority of the Internet Assigned Numbers Authority, IANA, allocates the network portions of IP addresses to Internet Service Providers, ISPs. ISPs are responsible for assigning the host portion of the IP address to machines within their local networks. IP addresses are unique. No 2 machines can have the same IP number. IP addresses are unique. No 2 machines can have the same IP number. IP addresses are also global and standardized. All machines connected to the Internet agree to use the same scheme for establishing an address.